Much of Earth's ocean water came from comets that crashed into the planet eons ago. In the early days of Earth, the planet's surface was anything but stable. Asteroids and comets constantly pummeled the surface. Life could not have survived long enough there to develop the process of photosynthesis to sustain it. But deep sea hydrothermal vents would have had all the necessary ingredients for life, life that relied on chemosynthesis rather than photosynthesis. Hydrothermal vents existed as soon as liquid water accumulated on Earth more than 4.2 billion years ago. As the Earth grew deeper, it would have insulated the vents from the bombardment going on at the surface, and its currents would have helped spread the new life from vent to vent. But as the Rose Garden, Rosebud, and Tempest Fugit vents show, the life of a hydrothermal vent is usually pretty brief, with most lasting only decades. Scientists needed to find a vent that had been stable for tens of thousands of years, long enough to allow life to begin, grow, and spread out. In 2000, Deborah Kelly, a professor at the University of Washington and a colleague of Tim, found just that. She was chief scientist on the expedition that discovered a vent now known as Lost City. It was the strangest vent field anyone had yet seen in any part of the world's ocean. In place of bulging black smoker chimneys were dozens of delicate cathedral-like spires of calcium carbonate, a compound commonly found in baking soda. Each was packed with new forms of life. More than half of the species the scientists saw had never been seen before. The water coming out of the vents was only 175 degrees Fahrenheit, about 500 degrees cooler than at some black smokers. Strangest of all, the system wasn't powered by seawater interacting with magma deep inside Earth. The team learned that the heat creating and supporting the Lost City vents comes from a chemical reaction of seawater and a rock in the mantle called olivine. When olivine reacts with seawater in a process called serpentinization, it creates a great deal of heat, methane, and other minerals that come straining up to the surface of the seafloor. From Lost City's size, scientists estimate that this process has been at work here for more than 30,000 years. Kelly and her team discovered a completely new deep-sea ecosystem. Another surprise, a thin film of archaea lined the vent. The life at Lost City isn't swimming around in the acidic flow of a volcanic stream as on the Galapagos Rift. Instead, the water here is highly alkaline, the opposite of acidic, and chemically closer to bleach. Scientists never thought life was possible in such an environment until they found it here. These soaring spires of the Lost City hydrothermal vent field, illuminated here by ROV lights, reveal the astonishing scale of the system's carbonite towers. The intense darkness of the deep means that seeing the full field is possible only through sonar mapping. Sonar mapping is the use of sound waves to create a three-dimensional map of a deep-sea location. Aliens among us. The deep sea and deep space may not seem like natural companions, but the secrets found in the innermost depths of the ocean may provide clues to unlocking one of the greatest mysteries in the universe. Are we alone? Some of the smallest creatures found at the hydrothermal vents may help solve the riddle. Hidden inside these vents are microorganisms known as extremophiles, organisms that thrive in environments that would be deadly to most life as we know it. Whether the environment is on the verge of boiling or under crushing pressure or extremely acidic or alkaline, life seems to adapt. Through all the trials and transformations of Earth, these microorganisms have been able to hang on even during periods of mass extinction, when large amounts of life on Earth died off. The vents are the secret to their success, using three simple ingredients: water, carbon, and an underground heat source. Hydrothermal vents can power an entire ecosystem far removed from the sun-powered world at the surface. For scientists, the idea that simple elements can sustain such complex ecosystems offers an intriguing possibility. Earth isn't the only planet in our solar system with that magical combination of heat, water, and carbon. The great geysers of Saturn's moon Enceladus have all these ingredients. So does Jupiter's moon Europa. Mars once did too. In fact, those three ingredients may be common throughout the universe. While we have been searching the skies for interstellar probes or flying Martians, the most likely aliens may not look like bug eyed beasts. Instead, they may resemble the tiny microscopic creatures hidden in the alien deep. The Earth isn't the only place with all the ingredients to support extremophile life. Jupiter's moon Europa is another possibility. Scientists are currently designing probes capable of exploring the oceans there, with the hope of finding extremophile bacteria like some of those already found on Earth. If life could live in environments like Lost City and Black Smokers, then was there any place too extreme for some form of life not only to survive, but also to thrive? The Archaea and the Age of the Lost City are tantalizing clues that offer glimpses back to the origin of all life on Earth. But this is not enough. The evidence that life began at hydrothermal vents is mounting, but we haven't proved it yet. Kelly believes that vents like Lost City can coexist with vents like Tempest Fugit or even Black Smokers. Such a hybrid world could provide the next step in the search. We just need to find it. We still don't know the exact environment where life on Earth began, but it is important to recognize that our explorations have already proved that life is possible in environments dominated by crushing pressure, extreme heat, acid baths, and alkaline springs. If life can exist in these extreme environments, and if all life, human or otherwise, is made up of some of the same basic building blocks, is it unreasonable to believe that it also exists in worlds beyond our own? There is only one way to find out: explore.